Hello Year 10. Today's lesson is looking at gravitational potential energy and kinetic energy. First thing for you to do then is to take your piece of paper, your lined piece of paper, put the title of gravitational potential energy and kinetic energy. Then I would like you to describe both of those energy stores and to provide examples of them. So this was covered in your last week's remote learning lesson on energy stores. Have a look at those notes that you've done for that lesson if you're struggling. You can also use your CGP book, which is the book that you've been provided. We are looking at pages 298 and 299 in that book. So in your or on your piece of paper now, I expect to see gravitational potential energy, a description of it and an example, and the same for kinetic energy. Pause the video now and complete those tasks. Okay, so your learning objectives for today then. Remember what we have is our key high level objective on the left hand side, which is to explain how energy can be transferred from the kinetic energy store to the gravitational energy store. Before we get to that stage, we need to be able to do the 2 bullet points on the right hand side. So in order to achieve that higher level objective, you first of all need to know what the equations are for calculating kinetic energy and gravitational potential energy. So you need to be able to state them, you need to be able to say and remember how to calculate those two things. Then you're going to have a go at actually calculating the kinetic energy and gravitational potential energy of different objects in different scenarios. You also need to be able to rearrange that equation. So we're going to have a practice at doing that. Why are we learning this? So at the bottom we have a link to IAG and NASA scientists looking at energies and how they utilize their effects in order to launch rockets. Okay, now for the remainder of this lesson then you're going to continue to need your lined pieces of paper. You're going to need a pen and a pencil and a ruler. You'll also need a calculator. So if you haven't got one or haven't got one to hand, pause the video now and go and make sure you've got each of those pieces of equipment. Okay, so gravitational potential energy. We'll start with this one first. So from your last lessons remote learning, looking at energy stores, gravitational potential energy, any object that is raised above the ground will have a gravitational potential energy store. So an object that you lift up in the air now, you pick up your pencil, you raise it up in the air, you will increase the gravitational potential energy store of that object. Okay, so the first equation we're going to look at then is for calculating gravitational potential energy. So we give gravitational potential energy the symbols GPE and we calculate it by doing a simple equation of mass times gravitational field strength times height. Okay, you don't need to write any of this down at the moment. I'm just going through the equation. I will give you some time in a minute. I'll ask you to pause the video and for you to construct a formula triangle using the equation and the information that I'm about to give you. Okay, so as I said, GPE is gravitational potential energy and it is given the units of capital J for joules. Mass is given the symbol of lowercase m and we're looking at units of kilograms or kg. Gravitational field strength essentially means the strength of gravity. We give it the symbol of G and it has the unit of newtons per kilogram. On Earth, it's pretty much the same wherever you are, and we're looking at roughly 9.8 newtons per kilogram. In an exam, they will give you the figure they want you to use for gravitational field strength. So not to worry too much about that. It will become clear when we go through an example. And height, finally, is given the symbol of lowercase h and the units of meters. Now, when I tell you to, I would like you to pause the video and to draw a triangle and to put that equation into the triangle. Now, we've done this before. However, you'll notice here what we have is GPE equals something times something times something, whereas normally we just have something equals something times something. So your bottom of your triangle is going to need 3 sections as opposed to just 2 sections. Okay, make sure you add the symbols, make sure you add the units as well. So don't just write GPE, Make sure you're writing the units of joules. Okay, so pause the video. Remember to use your ruler, draw your triangle, and put that equation into that now, please. Okay, thank you. Hopefully what you have is a triangle that looks very similar to this. So you've got GPE at the top and mass times gravitational field strength times height at the bottom. Remember how we use these triangles. If you are asked to find out what one of them is, so maybe you're asked what is mass, you would cover mass with your finger, and that would leave you GPE divided by gravitational field strength times height. Okay, so our example, first example for you to look at, here is our question. Gravitational field strength on Earth is 9.8 newtons per kilogram. An object has a mass of 10 kilograms and is raised by a height of 20 meters. What is the gravitational potential energy of the object? So remember, when we are working out answers to questions, the first step is to write down the equation that we are going to use. So we are asked about gravitational potential energy. We are given mass. We are given the units, the number for gravitational field strength, and we are given height. Therefore, the equation that we will use is GPE equals m times g times h. Okay, then on the line underneath that, you then put the numbers from the question to replace the symbols. So you put the numbers for mass, gravitational field strength, and height. So 10 times 9.8 times 20. All of those numbers we have been given in the question. And then finally on the third line, we put our answer, 1960, and we make sure that we are including our units, which is joules. Okay, remember this is our standard for setting out our working out and for doing our calculations. On the next slide is a question for you to work through. Okay, pause the video when you get onto the next slide and you can then work your way through that question. Okay, so your turn now then. An object of mass 12 kilograms is raised by a height of 3.5 meters, and we're doing this on Earth. Okay, what is the gravitational potential energy of the object? So what I want you to do here, guys, you don't have to write down the question on the piece of paper that you've got in front of you that you've been using so far. Okay, all I would like you to do is to put the question 1 and to just write down your 3-line answer. So remember, the first line, like we've just seen, is the equation that you're using. The second line, you put the numbers in from the question. And the third line, you put your answer with your units. Now you'll notice I haven't given you the number for gravitational field strength. However, the question gives you enough information in order to work out what that will be based on my previous example. Okay, so pause your video now, complete your question, and later on I'll ask you to upload an image of that. Okay, so the second part is looking at how do we calculate kinetic energy. So kinetic energy, given the symbol Ke, the way that we will calculate that is we would do a simple calculation of half, or 0.5, multiplied by m multiplied by b squared. Now m again stands for mass, and it's given the unit of kg, kilograms. Velocity is given the symbol v, and we measure that in meters per second. V squared just means v times v. So if velocity is 6, v squared would be 6 times 6. Okay, now again, we need to be able to put this into a triangle. Pause the video now and put it into a triangle, please, on your pieces of paper. Remember to use your ruler and your pencil to draw your triangle. Draw it out nice and neatly and press pause now. Okay, hopefully you got your triangle, which looks like the one on the left. So Ke at the top with half times m times b squared. Okay, now the equation at the bottom V equals, okay, sometimes you will be asked to work out velocity. Please don't be afraid of that equation. It is not at all complex, but you need to know it. Okay, so V for velocity equals the square root of kinetic energy divided by 0.5 times the mass. Now, when you're doing these equations to work out velocity, my suggestion would be to do KE divided by 0.5 times m to get your answer, and then find the square root of that, which is quite straightforward. On your calculator, you have a square root button which you can use to find the square root of any number. Okay, so an example then of using our equation to calculate KE. So here's our first question. An object has a mass of 3 kilograms and is moving with a velocity of 5 meters per second. Calculate the kinetic energy. Okay, you don't have to write anything here, guys. We're just going through and looking at how we actually set our answers out again. So the first thing to do is to write your equation down, which would be KE equals 0.5 times mass times velocity squared. Second line underneath now is where we put the numbers from the question. So KE equals 0.5 multiplied by 3, which is our mass, multiplied by 5 squared. So our velocity is given to us in the question as 5. So we need to square that. So essentially we are doing 5 times 5 multiplied by 3 multiplied by 0.5. And on our third line we then write the answer, which is 37.5, and not forgetting our units, which because it's energy is capital J for joules. Okay, the second example underneath is how we would use the second equation that we looked at in order to work out velocity. So a question might sound similar to: a sprinter has kinetic energy of 1000 joules and a mass of 68 kilograms. Calculate how fast the sprinter is running. So they haven't used the word velocity there, but they're expecting you to make that link between the words how fast and velocity. So the first thing we do is we write our equation, which is square root of KE divided by 0.5 times m. Okay, so we then secondly put our numbers in from our question. So you can see there we've got 1000, which is our kinetic energy, divided by 0.5 times 68. So if we did that equation and then found the square root of it, that will give us an answer of 5.42 meters per second. Okay, your turn now, guys. So we're using the two equations to answer these questions that we've just looked at. If you are struggling, go back, rewind the video back to look at my examples on the previous slide. The first question is a brick of mass 0.14 kilograms is dropped and moves with a velocity of 6 meters per second. Calculate the kinetic energy. So that is KE that we are calculating. And number 2 is a runner with a kinetic energy of 15,000 joules and a mass of 75 kilograms. What is the sprinter's velocity? Again, on your piece of paper now, you need to write out you don't have to write out the question, but you need to write out your answer as 3 lines. So I want to see the equation, then the numbers from the question, and then the answer. Don't forget your units. So write these out on your line pieces of paper. Pause the video now, and I will expect to see a screenshot of this uploaded when you've completed this lesson. Okay, guys, so the final thing we're going to look at today is conservation of energy. And how both kinetic energy and gravitational potential energy are linked. So essentially, as we've looked at previously, energy is not created or destroyed. All that is happening is that energy is being moved from one store to another. So essentially, we are moving energy from our gravitational potential energy store to our kinetic energy store, or vice versa. So if we gain kinetic energy store, that amount that we have gained in that store must be the same as the amount that's been lost from the gravitational potential energy store. Now, if we move on to look at the next slide. Okay, then final task, guys. So this is an exam question. What I'd like you to do for this question is just to write down the question itself, which is at the bottom. Write it down on your piece of paper, which the question is, explain the energy changes during this time. And what we have is a graph which shows the kinetic energy of a swing over a few swings. Now, what you need to think about is a swing, so a swing that you'd see in a park, and you imagine that swing moving, going from high up in the air, moving down towards the ground, and then moving back up into the air, and that continual motion of the swing going up and down. So you need to link that motion to gravitational potential energy and kinetic energy. So the graph in front of you shows you how the levels of kinetic energy will be changing over time. You need to think about how that will have an impact and what effect that would be having on the gravitational potential energy at the same time. So as the kinetic energy is high, what would the gravitational potential energy be like? And as the kinetic energy is decreasing, what would you expect to be happening to the gravitational potential energy? So bear those clues in mind. It's a 6-mark question, so we expect 6 bullet points here, please. Write down your 6 bullet points on your lined piece of paper. That's your final task for today's session. So what I'd like you to do is to take a screenshot or an image of all of the work that you've done today. Upload it, please, onto ClassCharts. And remember that the best work will get positive referrals. And if you work hard, you get rewarded. Thanks, guys.